Hello, good day. Today we'll be talking about mold materials in foundry. Type of material used in your cavity molding castings. Type of material you use in obtaining a desired pattern, which you have already talked about before. In the previous video we talked about pattern materials. Talk about the split pattern, skeleton, match plate pattern, coupe and draw pattern, single piece and multi-piece pattern, etc. So we have finished about pattern materials, talking about woods used in pattern making and others. So today we'll be talking about molding material. So the material that is best used in molding the pattern which you have already made, so that it can be used for your casting. So we'll be saying, let's read about material. So it's in general, any material which is workable and of higher refractoriness in nature can be used for mold making. Thus, the mold materials can be metallic as well as non-metallic. So it's either use a metallic mold material or use a non-metallic mold material. So either one. So it's types of under metallic mold materials, we have cast iron, we have mined steel, we have alloy steels, we have anodized aluminum. So these four are types of metal you can use in your molds. So in non-material molds, you can still use your molding sand, you can use your plaster of Paris POP, you can use your graphite, you can use your silicon carbide, and you can use your ceramic. So all these are the non-materials you can still use on mold in foundry molds. So they say, but out of all, molding sand is the most commonly used. So out of all of them, the sand is the most preferred used materials in foundry. So most molding sand is more preferred in foundry. So now we ask ourselves, why do we use molding sand? Why do we choose sand mostly in foundry? Why do technologists, why do engineers, why do everybody who knows something about foundry who want to make a casting, why do they choose the molding sand? So they say because of its high refractoriness nature. What is refractoriness? Refractoriness is the ability to withstand, of a substance or a material to withstand some pressures or temperature, to withstand temperature, heat mostly. So sand can withstand the heat of the molten metal. Sand cannot, the molten metal cannot dissolve the sand, it cannot reduce the sand grain when it comes in contact with the molten metal. So that's why it's mostly used. So, and also chemical and thermal stability at a higher temperature, high permeability. Sand can be worked on. Sand is easily to be worked on. So, and the workability along with good strength, sand has good strength and it's cheap and easily available. Almost everywhere in the world you can easily get a sand. So molding sand, the basic things to consider in getting your molding sand is one, the refractoriness. So the refractoriness of the sand makes it a very good thing for us. So they say the refractoriness to withstand high temperature without breaking down or fusing. Refractoriness is a highly important characteristic of molding sand, while other qualities indices of the sand can be improved upon a number of ways. Refractoriness can only be increased to a limited extent. Molding sand of inferior refractoriness with slag on the surface of the mold, and no such casting surface can be obtained. The degree of refractoriness depends on the, on the silicon oxide, which is otherwise the pot content. So what is sand? Pot is sand, so its coarse in nature. It's one like single spots of stores mix contain sand, and the shape and the grain size of the particles. So that's what quartz is all about. So the size, the grain shapes, sizes of the little sand, the smallest sand particle in the sand. Then the higher silicon content, and the rougher the composition, geometric composition. The higher the refractoriness of sand makes it the best to use. Refractoriness is measured by the center point of the sand rather than its melting point. So the center point of the sand is when sand starts lagging, not melting, So then the center point of the sand must be higher than the temperature at which molten metal is poured into the mold cavity.